Hey there. So we are going to talk today about intervals of increase and decrease. One thing that's really important to note here is that I broke up this lesson into a couple days. So you're going to see the second part of this lesson next week. And so in the assignment, we're going to be looking at 4.3. For a lot of these problems, we're going to just do A and B for this assignment, and then we'll do parts C on all of these problems as we go into the second part of this topic next week. So just something to pay attention to when you're looking at the homework, because you'll notice part C and you're like, I have no idea what any of those words mean. That's fine. I don't expect you to. So let's get ourselves ready for notes, and we are going to talk about intervals of increase and decrease. Now, what the idea here is that intervals of increase mean whenever the graph is getting bigger, whenever the function is increasing. So increase is when the function generally points upward. If I'm looking at this example, find the intervals where the function graph below is increasing and decreasing. The increasing section, there's one section here where the graph is going up, and there's a section here where the graph is going up, meaning that as we go from left to right, we're moving in an upward direction. Now, decrease is when the graph is pointing downward. So, I know the contrast here isn't super high. So here, in this middle section, that's where the graph is decreasing. And you'll notice they are bounded by the critical points, by the local min and max right here. And that's always going to be true. So in this case, our increasing, and I just want to do a little bit of interval notation, is that increasing goes, we are always talking about x values, so x is going from -3 to -2. That's our ending of our first section. Union, so with the interval from x equals 1 to +3. So on this interval, the graph is going up as well as on this one. In between then, these should be not inclusive because at those points it's 0. I apologize for that. These should be open bounds because they are neither increasing nor decreasing at these points, because that's where it is flat. It is 0. 0 is not a positive or a negative. So then it is decreasing. Again, still looking at x values from -2 to +1 in the center here. And again, at these points here, it is doing neither. So make sure you've got open bounds with parentheses. Now here in number 2, given a function 5 minus 3x squared plus x to the third, find the following: intervals of increase and decrease, local maximum, local minimum. So, sometimes you'll have the graph and you can just do what we've just done. Sometimes you're going to be given the functions here. So the idea with intervals of increase to decrease, intervals of increase is wherever f prime is positive, because that means the slope is going up. Similarly, decrease are where f prime is negative, meaning that the slope is going down. Just to recall from last week, local maximum means that f prime is going from positive, there's a point at 0, and then it's negative, and the minimum is where it's negative to positive. So the first thing that we want to do is you want to start with the critical points. So what I will do for the critical points is, remember, that is where f prime of x is equal to 0. Now in this case, the derivative is just a nice polynomial, would be 5 becomes 0, so then -3 times 2, which is 6x, plus 3x squared. Solving for 0, I'm going to factor. So I'll say 0 is equal to 3x times -2 plus x. So our critical points are at x equals 0 and 2. Now from there, we're going to do the number line test that we did last week. So we're going to look at our critical point values on x. So we've got 0 and 2. And we know that f prime is 0 and 0 for both of those. That's what it means to be a critical point. And we'll test other points in each interval. So in this case, I'm going to test -1, 1, and 3. And if you remember, that means that you want to find the f prime values of those points. So f prime of -1, f prime of 1, f prime of 3. And you can just plug that in to our formula right here. So -1 becomes 6 plus 3, so that's 9. +1 is -6 plus 3, -3. And 3 here is 9 again, meaning that we are looking at a positive interval, a negative interval. So +9, -3, +9 again. Now that we have our line test, all we need to do is draw our conclusions. So looking here, we can see that our interval of increase, where it's positive, is -infinity to 0 and 2 to +infinity, because we're looking at our interval positive, positive, and then we have a negative interval in between. This won't always be true, but it happened to have been true for the graph and this. Did not plan that out. In between 0 to 2 is decreasing. C, the maximum, is where it goes from positive to negative. So that is at x equals 0. You can plug in the point and you'll get 0, and you plug it into your f of 0. So this would be the 0, 5 is the local maximum. And the local minimum is at x equals 2, because we're going from negative to positive. And again, we can get the ordered pair, which is not 0, which would be 2, 1. Let me know if you have any questions, and remember, you're just doing A and B from the homework. Talk to y'all later.